12.8 spherical coordinates. Uh, Given a point x, y, z in rectangular coordinates, we have spherical coordinates. The order is rho, theta, phi. Rho is the distance from the origin to the point. If you drop this point x, y, z down to the xy plane, that would be x, y, 0. Theta is a polar theta. We simply draw a line segment. This is a length r from polar coordinates, and this theta, that's the counterclockwise theta from trigonometry, starting at the positive x-axis, going up toward the y-axis. And if you take this line segment rho, the angle down from the z-axis is what's called phi. The coordinates go in that order. To begin, here are a few points. So there's a point here, a point here, a point here, and a point here. Now let's call that P0, P1, P2, P3. We can convert those to spherical just by understanding what the variables are. So let's start with P0. Okay, rho is the distance from the origin to here. That's obviously 3. Theta is how far we go around, actually. Right here on the z-axis, it doesn't matter how much you go around. So you can just put some random number in there, like 86 degrees. It can really be anything. Now the angle we come down off the z-axis, well, we're right on the z-axis. So that's 0 degrees. This is always 0 on the plus z-axis. And when you're on the positive z-axis, this angle can really be anything. When we get to using these equations, you'll see why that is the case. And now let's try P1. We're here on the y-axis. Rho is equal to 4 units from here to here. Theta, we come from here to the positive y-axis. That's a 90-degree angle. And then phi, we'd have to draw phi from here down to the y-axis, and we get 90 degrees for phi. It's going to be 90 anytime we're in the xy plane. Anywhere in the xy plane takes us 90 degrees to get from the positive z down to that. Now let's see, P2 is down here on the negative z-axis. P2. Rho is equal to 3. Notice rho is always a distance, so we don't make it negative 3. Theta can be anything. I'll make it 86 degrees, just like before. And now phi, how far is it from here to here? Well, that's a straight angle. That's 180 degrees. That's always a negative z axis. Phi equals 180 degrees. Okay. And then we finally have that's P2. We have P3. That's 3 units. Theta, we start at the x-axis, and, well, we don't go anywhere. We're already on the x-axis. That's 0 degrees. And phi, from here to here, is a right angle. Start here, come down. So I'll start here and come down, 90 degrees. Okay. Those ones are easy. Now let's suppose we have rho theta phi equals 2, 45 degrees, 45 degrees. Not that easy to convert that. We would be over 45 degrees, down 45 degrees. We would be somewhere here in space. And we want to know what the rectangular coordinates are. Well, can simply use these equations. I'll explain in part 2. I'll derive these for you. I'll explain where the equations come from. For now, let's just go ahead and use them. X equals 2 sine 45 cosine 45. We simply put 45 and 45 in. Okay, square root of 2 over 2, square root of 2 over 2. Okay, that's really just a 2. 2 times 2 is 4, and 4 over 4, guess what? We get 1. Y equals 2 sine 45. Sine 45, cosine 45, same thing. And that's going to be 1 as well. Z equals rho cosine phi. Okay, 2 cosine 45, 2 radical 2 over 2 in radical 2. Okay, that's always very simple. Converting from spherical to rectangular, straight computation. So let's do one more example, and I'll show you how to go from rectangular to spherical. It could be a little more complicated. Let's suppose we take the point rho theta phi equals 2 38 degrees, 0 degrees. Now that'd be a point right here, just below that point right there. And I said that 38 degrees doesn't really matter. And let me show you why. Let's calculate x, y, and z. X equals rho sine phi cosine 38. And guess what sine of 0 is? That's 0. 2 times 0 times some irrational number is 0. Y equals 2 sine 0 sine 38. Sine 0 still 0, hasn't changed, and we get 0. Z equals rho cosine phi 2 cosine 0. Cosine 0 is 1. 2 times 1 or 2. 0, 0, 2. Guess what? That's this point right here. Okay. Now going the other way, let's suppose we have, for instance, -2, -2, 3, x, y, and z. We want to know rho theta phi. Well, we're going to use these equations right here to find rho theta and phi. Of course, there's some trigonometry involved, so it's not so simple. Let's start with rho. Rho squared is -2 squared. Yeah, we got 4 and 4 is 8, and 9 is 17. Rho is square root of 17. Rho is generally positive. We'll talk about that in a minute. Tan theta is equal to y over x equals 1. And the simplest way to find theta is draw an XY sketch. Okay, just forget about z for a minute. XY -2, -2, that's over here. This angle here you can call the reference angle. And the reference angle is inverse tangent, absolute value -1 over -1. Okay, it's just this is just simply a right triangle trigonometry problem. We're not interested in positives or negatives. And in this case, we get 45 degrees. Okay, inverse tangent of 1, or negative, sorry about that, it should be negative 2 over negative 2. And we get 45 degrees. Well, guess what? We want this whole angle, right? We want the angle from the positive x-axis. So theta is going to be 180 plus 45, or 225 degrees. Now phi, the range of phi is 0 to 180. We can say cosine phi is equal to z, which is 3. This is really rho down here. So presumably we've already calculated rho. And then we can say phi is inverse cosine 3 over radical 17. This formula works whether or not it's positive or negative. Cosine will give us the inverse in answer from 0 to 180. It is what it is. No need to use a reference angle. So I'll just leave this at this. You can certainly use your calculator without any issue. So that's the way you convert from rectangular to spherical. Okay, rho, straight calculation. Phi, straight calculation. Theta, you may have to use a reference angle, unless you could eyeball it. You know this is a 45 over 2 down 2. Sometimes you can just eyeball it, but nonetheless use a reference angle idea. Okay. One more thing as far as these variables, rho is a distance. Distance is non-negative, so generally 0 is less than or equal to rho less than infinity. Okay, rho equals 0 is right here at the origin. Theta positive this way, negative that way. Theta can be as large as we want. So for instance, theta equals 3 pi means we go around once and then another pi would be back on the negative x-axis. So you can go around multiple times. Phi, on the other hand, phi is a minimum of 0, maximum 180. You can't get any further away from here than 180. So phi, okay, is between 0 and 180. This is the plus z-axis. This is the negative z-axis. Halfway in between is the xy plane. Okay? Okay, that's about all we do. This information is sufficient to do spherical coordinates on your first exam. We'll be back with a part 2. We'll call this part 1. Part 2, I'll derive these equations for you. It's not a bad idea. If you work with this for a while, get used to the coordinates. It's not that difficult to understand the derivations, but it's better if you look at the derivations after you spend a little bit of time familiarizing yourself with what these spherical variables are. So.